this video, we're going to be covering another Amazon interview question. This is Leetcode question number 42, trapping rainwater. This is a hard question, really hard to come up with the logic if you haven't done it in half an hour time frame. Uh, we're going to be going with this example. It's really hard to actually, the way we're going to be doing it is like we're going to be have our algorithm, and then based on that we're going to be talking about how the algorithm works. Basically, you have a pointer on the left hand side, a pointer on the right hand side. You compare the heights of both, and then if the height of the left hand pointer is less, you're gonna see if the current height is like, how does it compare with the left maximum you have seen so far. If it is less, basically you're gonna be adding the average. If it is increasing, let's see if this is a block over here and another block with a bigger height over here and another block, so there would be no water which can be trapped. It's gonna be like a hill, and there would be no water on the left hand side. So we're gonna keep incrementing the left counter if the height keeps increasing. If the height does decrease, we're gonna have the difference, and that's gonna get added to the result. Similarly, we're going to be doing the same thing, very similar thing to the right hand side. If it is like, if you see a bigger number, like a hill, like kind of a hill, it's basically saying that uh, like if you are going like this, because we're going to be going from right to left for the right pointer. So if you see, if the next index which you are working on, if the height is greater, it's just gonna say that update the maximum right you have seen so far. But if it is less than the height of the maximum right you have seen so far, then you're gonna be adding the difference in the result, and you're gonna keep doing until the left pointer becomes uh, is no more less sorry left index is no more smaller than the right index. Okay, so our left index is gonna be here, the right index is gonna be here. We're gonna have a couple of things. We're gonna have our left max initiated as right, as 0, right max initiated as 0, and answer is gonna be 0. We're gonna see, the first thing we are seeing is like, as long we're gonna keep doing as long as the left is less than the right. The first thing we want to check is the height of the left is less than the height of the right. So yes, in this case, height of the left is less than the height of the right. So we're gonna be basically processing the left hand side. The right is not gonna be altered in any form or way. So the next thing we want to see is that this current height, which is 0, is it greater than or equal to the left max you have seen so far? So yes, it is equal. So all we need to do is to update our left max to the same thing, and then increment the left. Nothing is going to be added to the answer. Then again, you're going to compare if the left max left height is less than the right height. No, they are equal. This time we're only gonna process the right hand side, and we don't want to change anything to the left. So the right one, is it equal or greater than the left max? Yes, it is greater than uh, the right max you have seen so far. So that's gonna get updated, and we're gonna decrement the right pointer, as you can see over here. Okay, compare this one. Is the left height is less than the right height? Yes, it is less than the right height. This time we're only gonna process the left hand side. Is this the height greater than the left max left you have seen so far? Yes, that is the case. We're only gonna increment it, and that would be it. Is the left less than the right? Yes, it is. So this time we're gonna compare, is it less, is it greater than or equal to the left max you have seen so far? No, it is less. So this time we're gonna say that 0 plus the difference of left max minus the current height, which is 1. That's gonna be the answer, and we want to increment that again. And you can notice that this one didn't change, so this one stayed where it was. So again, is the left hand side less than the right, the height of the right index? No, it is not. It is equal. So this time we're only gonna process the we only want to process the right hand side. That being said, is 2 is this time greater than the maximum right you have seen so far, so we're going to update that and decrement it. We're going to compare this again. Is it less than that? No, it is not. We own, but this time this is less than the maximum you have seen so far, so that's gonna stay there, but answer is gonna be updated as 1, the previous one, plus 2 left max, sorry, right max minus the current height of the right, which is 1. So 2 minus 1 is 1. That's gonna make it 2, and we want to decrement it again. Is it less than? No, it is not. So basically, is it equal? Yes. So is the right max less than or equal to 2? Yes, it is equal to 2, so that's just gonna stay 2, and that's gonna get decremented. So this condition over here basically checks if the height is greater or less or equal to the right max. And in either way, even if it is right equal, we wanna just update that and don't touch the result or the answer. Okay, that being said, uh, is it less than the right hand side? Yes, only sorry, left is gonna get updated. So is it greater than the left max you have seen? So, greater than or equal to? Yes, it is equal to. No, it is actually greater than. So basically, is this height greater than or equal to the left max? No, it is not. Right? It is greater than. So yes, the height is greater than that, so all you need to do is to update that and then increment it. Again, this side is less than the right hand side. We're going to process the left hand side. Is that height greater than or equal to this one? No, it is less than that. So this is not going to be touched, the left max. The only thing is we're going to update the answer by 2 plus 2 minus 1, which is going to make it 3. Right, and then this is going to get incremented. Is that so left height is less than the right height? Is that height greater than or equal to the left max you have seen so far? It is not greater than or equal to, it is less, so that's gonna stay there, but the answer is gonna get incremented by 2 minus 0, which is 2. It's gonna make it 5. Okay, and then this is gonna be incremented. Okay, the left hand side is still less than the right hand side. We're going to process the left hand side only. Is this height greater than or equal to the left max you have seen so far? No, it is not, so the answer is going to be updated. 5 plus 2 minus 1, which is 1, is going to be equal to 6. Okay, this is going to become L is gonna go over here. L is no more less than the right, so we're gonna stop processing it, and we're gonna be returning the answer. That's all how it works. And in terms of the complexity, we're not using any extra space, and we are just going through like it's gonna be one iteration. It's gonna be linear O of n. It's gonna be the time complexity, n being the total number of heights. Yeah. That's all I wanted to cover in this video. Thanks for watching.